This lesson is transform the quadratic form of this problem into a quadratic form with no cross product term. So first step, we need to rewrite this equation into matrix. Okay, so this is x1, x1, x2, and x2. So based on that information, you have a matrix of 2 by 2. This is the first position. This is the second position. This is the third, and this is the fourth. Okay, so one more time. Based on this information, x1 will be first spot. x1, 2 will be the second spot, but there are two of them. So x1, 2 down here, and then x2 will be the last spot. So spot 1, spot 2, spot 3, spot 4. So x1 will be the 1, okay? x2 will be a 1 because the coefficient is 1. The coefficient is 1. However, x1, 2, there are two spots. Since there are two spots, we're going to divide it by 2. So 10 divided by 2 gives me 5. So you will put 5 here and 5 here. So that is our matrix 2 by 2. One more time. x1, because this is coefficient 1, will be here. This right here will be the last spot, which is 4. And the coefficient is 1, so 1. Okay, and where did the 5 come from? So half of this, which is 2, so 10 divided by 2 gives me 5. So I put here and here. And another reason why we divide by 2, because there are two spots. There are two spots that has 1, 2 and 1, 2. Okay, so one more time. This equation is rewritten in this matrix 2 by 2, where this is x1, this is x12, this is also x12, and this is x2. The 1 is because the coefficient is 1. There's another 1 here because this is a 1. Where the 5 come from? Divide 10 into 2. Why there are 2? Because I have one spot and another spot which have the same label. So that's why I divide by 2. So 10 divided by 2 gives me 5. So that's where I got the 5 here and the 5 here. Okay, so one more time. First spot right here. This is the last spot, which is here. And the spot for x1 and x2, there are two places. Divide by 2. So 10 divided by 2 gives me that 5 in the second spot and the third spot. Okay, so first spot, second, third, and fourth. Okay, so again, this equation is rewritten into this matrix 1, 5, 5, 1. And if we transpose this, it becomes 1, 5, 5, 1 again. So column, 2 row, column, 2 row, and they are symmetric. Okay, next step is pretty much the same as the other videos. Find the determinant so that I can get my eigenvalue. Now, a lot of steps will be skipped, so I'm assuming that we remember how to do this. Okay, so second step, we want the determinant using lambda so that I can get my eigenvalue. Once I have my eigenvalue, I can get my eigenvector. From the eigenvector, I can get the normalized eigenvector. Okay, so again, this is my eigenvalue. This is my eigenvector. This is my normalized eigenvector. Okay, so the normalized eigenvector came from regular eigenvector. regular eigenvector came from the eigenvalue. Okay, so your P is the normalized eigenvector. Okay, so again, this is normalized eigenvector, which came from the regular eigenvector. Regular eigenvector came from eigenvalue. Now there's a lot of step here that's being skipped. I'm assuming you remember how to get them. Okay, next, this is our diagonalized matrix, which only contain the eigenvalue 6 and -4. Okay, so one more time from the top. You are going to rewrite this equation into matrix form. Now here I have 2 by 2 because I only have one spot, which is here. This spot right here, there are 2 places, 1 and 2. And this is the last spot, which is here. So that's why it's a 2 by 2. The 1 came from the coefficient. This one also came from the coefficient. The 5, where did that came from? Since there are 2 places that has 1 and 2, so 10 divided by 2 gives me the 5 here and the 5 here. Transpose them so that column become row, column become row. And since they are symmetric, okay, so they are symmetric. Next, find the determinant, which you should know by now, so that I can get my eigenvalue. Okay, again, a lot of steps will be skipped. Okay, next, using the eigenvalue so that I can get my eigenvector. Okay, so here is my eigenvalue for 6 and for -4. This is the eigenvector belong to 6. This is the eigenvector belong to -4. Normalize this, so that's what it becomes. Okay, so again, this right here is the normalized eigenvector, which came from regular eigenvector. Regular eigenvector came from the eigenvalue. Okay, and the eigenvalue came from finding the determinant of A using lambda. All right, so be very careful on how to change this equation into the matrix. Use the matrix to get the eigenvalue through the determinant. Once I have the eigenvalue, find the regular eigenvector. Regular eigenvector become normalized eigenvector. This matrix is the normalized eigenvector. This matrix is the eigenvalue. Now, I hope you remember this formula is only for diagonalize. Diagonalize, only use regular eigenvector. Orthogonal diagonalize will use the normalized eigenvector. Okay, so be very careful between these two. Now the last step is very easy, even though it looks complicated. So all they want us to do is this. Even though what I wrote here is very confusing, but in simplest explanations, you're going to take the diagonalized matrix and rewrite it as this: 6y1 squared minus 4y2 squared. So the diagonalized matrix will be the variable y. This is the first spot. This is the last spot. And there's nothing here. And there's nothing here. So we only take care of the diagonalized or the eigenvalue only. Okay, so one more time. You're going to take the eigenvalue matrix and write it as 6y1 2 minus 4y2 2. So it's just this spot right here. This is y1, and this spot will be y2. Okay, that's all they're asking us to do, is to write the diagonalized matrix that has the eigenvalue into the y form. Instead of x, we use y form. Okay, so the original matrix is in x form. The diagonalized, all right, the diagonalized with eigenvalue is written in y form. Okay, so 1 is in this spot, 2 is in this spot, and there's nothing here and there's nothing here, so we don't need them. Okay, so again, the diagonalized matrix that contain the eigenvalue is rewritten in y form. Okay, so this is what they want us to do, and this is the answer that we need. Okay, even though what I wrote here is very confusing, but in simplest form of explanations, you're going to rewrite the diagonal matrix that has the eigenvalue into the y form. Okay, so 1 is in this spot, 2 is in this spot. Okay, and we don't need these two spots because they are 0.